Hello mathematicians. We're here today to talk about data and graphing and asking and answering questions that have to do with the types of graphs that we've been learning about in 4th grade. We're going to take a look at what we've done so far. In 4th grade, what we want to do is represent and interpret data, and we also want to be able to add and subtract whole numbers. Right now we're focused on adding and subtracting to help us solve questions about the graphs that we are seeing and creating. So the things that you need to learn in 4th grade, you need to know what a bar graph is and how to interpret that, what a line plot is, frequency tables, and then also know the difference between numerical and categorical data. All of that we're going to review right here in this little video to possibly help you with your homework tonight. You can also come back to these videos to help you prepare for assessments and things like that. Okay, so let's get started. If you take a look down here, we're going to start right here with this bar graph. The kids are very familiar with this. We have favorite ice cream flavors, and it's important to make sure that we label all of the parts. That graphs have a title, that our axes are labeled. Down here we have flavors, and up here we have number of people. You might see different scales along the side. Here we're counting by 2s, but you could easily see counting by 10s or 1s or 20s, depending on the data results you have and the range of numbers that you have. Along the bottom, usually we are labeling our bars with what they represent. So here we have chocolate, vanilla, and strawberry as different options for favorite ice cream flavors. Students have learned that they, when they're collecting data, they aren't going to go right to a graph. They are going to often create some kind of data table to record that. We've been using a frequency table. And how frequently does someone answer a certain way, and you record that usually with a tally mark. And then what we do is transfer that tally mark to a number representation. So here we have 2, 4, and 8, and you can see those numbers reflected over there in our bars that also match up. So students will need to know the tally system of 4 tallies, and when you get a 5th, you make a group of 5. Single tallies just represent 1. This equals 5. Okay. Then if you hop over here to this type of graph, it's called a line plot. It's one that's more unfamiliar to us, so we've been practicing that one a little bit more. I'm going to show you right now how we can take this same data and represent it on a line plot. You'll see that a line plot doesn't give you maybe as many details as a bar graph could, but they can also be useful in certain situations. So on a line plot, there is a line along the bottom, a horizontal line along the bottom, just like a number line. And that's why I tell the kids, it is a number line. It's going to need numbers on it that represent the range of your data. So our range was 0 to 8, so I partitioned my line plot to be 0 to 8. X's on this line plot will represent different flavors. I don't even need to mark the different flavors specifically. It's just a flavor. There's another example. It doesn't give as much detail. So as I look at my frequency table, I see that chocolate received 2 votes. Well, this means 2 votes, and I had 1 flavor, chocolate, get 2 votes. So I indicate that with an X. Vanilla received 4 votes. So I find the 4 and I indicate that flavor with an X. I'm not putting 4 X's above the 4. 1 flavor received 4 votes is what that would be saying. If I were to put 4 X's above the 4, that would mean that 4 flavors each received 4 votes, like a 4-way tie, and that's not what our data shows. Strawberry had 8 votes. Now let's say if we had chocolate chip in our survey, and chocolate chip, CC, also got 8 votes. Then I would go ahead and put an X on top of the strawberry X to show that 2 flavors received 8 votes. Now let's talk about the types of questions you might see when you're looking at graphs. If we hop back over here to the bar graph, one question you might get is very straightforward. How many people voted for strawberry? Well, there's no equation needed. You can just look at the graph. There's my strawberry bar. 8 people voted for strawberry. Very straightforward. When it gets a little more complicated is when you get a question like this. How many more people voted for strawberry than chocolate and vanilla combined? Wow, that sounds like a lot is going on. I have to combine chocolate and vanilla, and then I have to say how many more. So we're looking at multi-step problems involving addition and subtraction. These numbers are relatively small. A lot of us might be able to do that in our head, but I really encourage students to write down equations to keep track of their thinking. So, how many more strawberry than chocolate and vanilla? Strawberry has 8. Chocolate and vanilla combined is 2 plus 4. Sorry about that announcement there. Hopefully that wasn't too disruptive. 2 plus 4 equals 6. So chocolate and vanilla combined is 6. How many more? That means I need to find a difference. I need to compare my 8 with a 6 and see what the difference is. 2. 2 more people chose strawberry than chocolate and vanilla combined. Especially important to record equations when the numbers become larger that we're working with. Another type of question looking at the line plot that students might get is, how many flavors of ice cream were in the survey? Well, if you look here, X equals a flavor, so to find out how many flavors, you would count your X's. 1, 2, 3, 4. Another question is, how many more votes did the 2 most popular flavors get than the least popular flavor? So 8 represents the votes for the most popular flavor. 2 represents the votes for the least popular. And we're not even worrying about X's right now. We had to notice where the X's were to start with to find popular and least popular. But to find out how many more votes, you're really subtracting the numbers along the bottom of the line plot. Now we're going to take a look at the numerical versus categorical data. Over here I have a list of 4 questions that might be survey questions. And when we think about giving an answer to that survey question, if we're answering with a number, then that's our numerical data. Numerical just is a fancy word for number. If we have to answer with some kind of category, like a type, flavor, or animal, or something like that, then that's a category of data. So we're just going to practice real quick. How long did you read last night? I read 20 minutes. Maybe I read 40 minutes, 60 minutes. I'm answering in numbers. So that's going to be numerical data. How many students walked to school? 100 students walked to school. 5 students walked to school. I'm answering with a number, numerical data. What is your favorite animal? Well, if I answer that question, I'm going to be answering with a type of animal, a giraffe, a lion, an elephant. That means that's a categorical question. And what toppings do you like on pizza? I would not answer with a number there. I would say pepperoni, cheese, ham. So that would be categorical data. Here, vanilla ice cream was categorical data. Had I flipped it around and I said, how many scoops of ice cream did you get on your ice cream cone last night? I could still have an ice cream graph that showed numerical data instead of categorical data. So that is our data unit. We have a few more days left in it. This should help you be able to work on your homework tonight and review for our assessment when the time comes.